4.1c, let's see how you did. When we integrate this 8, we want 8x because the derivative of 8x is just 8. And don't forget your plus c. Next one, we integrate x to the 4th, we add 1 to the 4, and that gives us 5s, and we multiply by 1/5 plus c. Okay, this one we're going to change to the integration of x to 1/3 dx. So in here we're going to add 1/3 plus 1, all over 1/3 plus 1 plus c. And that ends up being 1 over 1/3 plus 1 is 4/3, x to 4/3 plus c, and that will just equal 3/4 x to 4/3 plus c. Put a little c in there. Okay, and our last one, we're going to bring this up to x to the -3 dx. Adding 1, we get x to the -2 all over 1 over -2, and that's going to equal -1 over x squared, and we need a 2 next to that because of that 2. And then what else do we need? Correct, our plus c. Okay, really good. We have some properties for antiderivatives. Properties for antiderivatives. All right, so the first property is if we integrate some constant times f of x dx, then that means we can pull out the constant and integrate f of x dx. Okay, so here's an example of doing that. Let's integrate 2x cubed dx. Following this first property, we can bring the 2 out and leave the x cubed dx in the integration sign. Okay, so now we're going to keep out our 2. We're going to add 1, divide by that same number, plus c. Now note, when we go ahead and distribute this, we have 2/4 x to the 4th plus 2c, which is 1/2 x to the 4th. Now plus 2c is still a constant, so we don't really write plus 2c, we just write plus c. So this would be the correct answer. Okay, so that was the first property. Let me write the second property down now. The second property states if we integrate and we have f of x plus or minus another function, g of x dx, that just equals, we can split them up. Now we can only split them up if it's plus or minus. It does not work for multiplication or division. Okay? All right, so let's do an example of that. We're going to integrate x to the 5th plus x to the 4th dx. According to this property, we can go ahead and split them. This is a plus sign. So we're going to integrate x to the 5th dx plus the integral of x to the 4th dx. Now let's continue on this problem. We're going to add 1 to 5, and we're going to divide by that same number. We're going to add 1 to 4 and divide by that same number. And then we have our plus c. Okay, so let's do an example of this. A little bit more complicated. Okay, not too bad though. So we're going to integrate all of this. 3x to the 4th plus 6x squared minus 2x plus 8 dx. Now there's a couple of ways of doing this, but I'm going to show you one way to start. We're going to split them all up. So splitting them up, we have 3x4 dx plus the integral of 6x squared dx minus, because of that minus, the integral of 2x dx plus the integral of 8 dx. Okay, so we split it all up by property 2, but property 1 says we can bring the constants in front. So I'm going to bring the constants in front. Now notice when you're working on your own, you can do this in one step. You can go from here to here. Okay, so we're going to bring out our constants. And this one we'll just leave as it is. Now from here, we can go ahead and integrate each one. So here we keep the 3 as it is, add 1 to the 4 gives us 5 times 1/5. Then we move to the next one. We're going to add 1 here, that gives us x to the 3, divided by 3, and we're going to times it by our 6. Notice how I just automatically went there instead of writing it to the side. You can do that too. Okay, now we keep our -2, we add 1, and we divide by that number, which is 2. Derivative of a constant is 8x, and then we always put our plus c. All right, so let's finish this completely. We have 3/5 x to the 5th plus 2 x cubed minus x squared plus 8x plus c. Okay, now I'm going to have you do one in your groups. Same type of problem. Okay, here you go. You're going to integrate 5x cubed plus 4x squared plus 3x all to the dx.